This is the solution video for question 20 from paper 2 of the 2019 TMUA exam. This question asks us to consider a graph y equals f of x. Now, we're told that the y equals f of x graph is reflected in the y-axis, then it is translated by 2 units in the negative x direction, and the result is the graph of the function y equals g of x. Then, when y equals f of x, up here, is translated by 2 units in the negative x direction, then reflected in the y-axis, the result is the graph y equals h of x. And then we're asked, from this, with our two graphs g of x and h of x, which of the following is a necessary and sufficient condition for y equals g of x and y equals h of x to be the same graph? And these are the options for what necessary and sufficient condition we could have, and they talk about the function being periodic or having some kind of symmetry to some extent. So there's a variety of options there, and we have to find the necessary and sufficient one. The key to this question is to keep a very tight measure on what's happening when we transform f of x to g of x and f of x to h of x respectively, and to try and get an accurate result of what g of x is in terms of f of x, and similarly with h of x. So let's start with g of x. So what we're going to do is we're going to look at this as well, because we're going to look at the reflection, translation, etc. and get g as f of something like x plus 2, x plus 3, etc. But if we look at what happens to y equals x, we can verify our answer quite nicely and see if what we're doing graphically with this, i.e. reflecting it, etc., matches with what we say the functions will do. Because it's very hard, it's very easy to get mixed up in a function, so to have some real world example to bring you back and check is very useful. So we're looking at y equals f of minus x because we reflect in the y-axis. And on this, we simply reflect this line, and we can quite easily see that's y equals minus x. And then what do? We translate by 2 units in the negative x direction. So we think we should get minus lots of x plus 2, because we substitute in x for x plus 2 if we translate 2 units in the negative x direction. We can simplify that to f of minus x minus 2. And so let's have a look at this graph. If we translate 2 units in negative x direction, we go this way. So we get this with minus 2 and minus 2. And we see that here, when f of x was just x, our graph matches this. So we've at least got some indicator that we have done this correctly. So this is what our graph g of x looks like, y equals f of minus x minus 2. We now do exactly the same for h of x. So h of x, of y equals x, drawn again. So firstly, we translate 2 units in the negative x direction, so y equals f of x plus 2. And what would this graph look like? Well, we just translate 2 units to the left, so we get this because the 0 moves to minus 2. And then what do? We reflect in the y-axis, so we need to change the x to a minus x, because now we're taking a function. Every time we take a function of x, we're actually looking at the output of minus x. And what happens when we reflect this graphically? Well, we'll just get a line going down here. So y equals minus x plus 2. And once again, very reassuring, because we see this matches with this. Because y equals x, so f of minus x plus 2 should be y equals minus x plus 2 for this line, which indeed it is when we graphically did all our transformations. The only thing that remains to do is to try and deduce our answer. So for these two graphs to be the same, what do we need? Well, we need for every x the output to match up. So we need minus x plus 2 to equal minus x minus 2 for every x. I.e., if we take any 2 points with a distance of 4 from each other, they need to have the same value when we apply f. And if we look through our conditions, that is clearly stipulated by B, option B, and so our answer is B.